Now in this video I'm basically going to focus on one-sided limits that involve L'Hopital's rule. But now if you look at this limit here, the one we're approaching pi from the left. The reason being, you can consider the composition of this. You can basically see, you can say you have an initial function, or one function to be the square root of x and another function to be sine x. So then that means that f compo g will just be the square root of sine x. And now if you consider the function sine x, if you consider the function sine x, it's basically gonna look something like this. It's gonna be something like this. It's a wave-like function. So you'll have pi there. And now notice that when you approach pi from the left, basically you're moving from the left because of this one. So I'm moving from the left. Notice that it's a positive answer. And if you're approaching that from the right, notice that you have a negative, which won't work because the domain must output that x is positive. That means that when you compose this, that means that you're gonna have to get that sine x must be positive. So you must get sine x between 0 and pi. So that's why we're approaching it from the left, because that's where sine is positive. So that's one of the factors you have to look at. Now applying LHOP, now notice that when we approach pi of x squared minus pi x, that means that we'll have to have 0, because we're basically going to substitute pi here. So you'll have pi squared minus pi squared. And sine pi, it's basically 0. So you have a 0 over 0. That's just the condition that you have to apply L'Hopital's rule on. So let's do that now. So you're going to have the limit when x approaches pi from the left of, if you derivate the numerator, you're going to have 2x. And if you derivate the denominator, you're going to derivate the inside, which is cos x. When you derivate the inside, you're going to have cos x. Then you divide by 2 the square root of that function. So you're just going to have 2 the square root of sine x. So now you're basically going to multiply both numerator and the denominator by 2 the square root of sine x. So you have the limit when x approaches pi from the left of 2x multiplied by 2 the square root of sine x divided by cos x. When you multiply both numerator and the denominator by 2 the square root of sine x, so you're basically going to have something like this. So now when we approach pi, notice that cos pi is minus 1, so we have a defined state on that. So this cosine pi will just basically be minus 1, and sine pi is just gonna basically, from the left, notice that from the left you are basically approaching 0 on that. So it is defined, so you're just gonna have 0 multiplied by anything is gonna be 0. So you have 0 over minus 1, so which is just gonna be 0. So the limits of this when we approach pi from the left, notice that the limit from the right does not exist, because this will not be in the domain. Sine x cannot be negative, because the square root. Know that the square root, what's inside the square root must always be positive for it to be defined. So the limit is going to be 0 of this case. So now let's say that we want to evaluate the limit when x approaches 1 from the right of the square root of x minus 1 divided by the square root of x plus 3 minus 2. So let's say we want to evaluate the limit when x approaches 1 from the right. From the right, because if you consider the function the square root of x minus 1, it's basically going to look something like this. Notice that the function has a domain from 1 up until infinity. The domain of this upper function is from 1 to infinity. So that means that we have to basically approach it from the right, because from the left it doesn't exist. It doesn't exist because it's not in the domain of that. So that's why you have this part from the right now. So notice that when we approach 1, this function will be 0. And if you approach 1 here, you're going to have 1 plus 3, which is 4. The square root of 4 is 2. 2 minus 2 is 0. So you have a 0 over 0 condition there. So you're basically going to have to use L'Hopital's rule there. So you have the limit when x approaches x approaches 1 from the right, and then you derivate the numerator, which is going to have the derivative of the inside, which is 1, and you divide by 2 the square root of what's inside. Then you derivate the denominator, which is just going to be the derivative of the inside, which is 1, divided by 2 the square root of x plus 3. So that's when you differentiate that. But now notice that you can basically do some quick algebra and simplify that. So you have limit when x approaches 1 from the right. So you're just going to basically multiply both numerator and the denominator by 2 the square root of x plus 1. So all I'm going to do is I'm going to multiply everything both numerator, this is the numerator and this is the denominator. You're basically going to multiply everything by 2, the square root of x minus 1, multiplied by 2, the square root of x plus 3. Notice that if you multiply the numerator by this term will cancel with this one and you'll be left with 2, the square root of x plus 3. And if you multiply the denominator by this term, then 2, the square root of x plus 3 will cancel with this one and you'll be left with 2, the square root of x minus 1. So now notice that the 2 and 2 will cancel each other. So you basically have the limit when x approaches 1 from the right of the square root of x plus 3 divided by the square root of x minus 1. Now notice that now the denominator is going to approach 2 because the square root of 4 is 2. Now notice that you're going to divide this by a very small number. What happens when you divide a fraction by a small number, or what happens when you divide by a small number? So you're basically going to have infinity. So we're basically going to approach infinity because when we approach 1 on the square root of x minus 1, when you approach 1, this is going to be approaching 0. And when you divide by nearly 0, you're going to approach infinity. So so the limit to that is basically going to be infinity. So that's how you can like evaluate that limit. Now what about if we have some absolute values instead? So let's say we are approaching 3 from the left of the absolute value of x minus 6 minus 3 divided by the absolute value of 2x minus 6. So let's say we have that. Let's say we want to evaluate this limit now. Now notice that if you try to like read the definition of absolute value, if you consider the inside function, which is just x minus 6, and the absolute value just reflects the negative part of that function about the x-axis. So if you try to like graph that function, it's basically gonna look something like this. So that means that we'll have a critical number at 6 if you look at this one. So that means that between 0 and all x values less than 6, this absolute value will just be negative into x minus 6. I'm doing this because we basically know that the 3 that we are approaching is on the left of that. So just going to be minus x minus 6, and then you keep the negative 3 like that. And so is true for 2x minus 6, except we're going to have the critical number at 3 if you look at that. That's because at 3, that's where the absolute value will basically be 0. So now notice that we are approaching it from the left, and if we're approaching it from the left, that means we'll have to like take negative of that. So it's just going to basically be minus into 2x minus 6. So you have the limit when x approaches 3 from the left. So this limit can be expressed as this one. So now let's further simplify this. So we have the limit when x approaches 3 from from the left. So now you're gonna have minus x, and then negative into negative is gonna be positive. So it's gonna be plus 6 minus 3. So which is basically gonna be positive 3. And now if you take the negative in, you're just gonna have minus 2x plus 6. So now basically now since you have this, notice that you can like factor by negative. You can factor by negative on this one, so you'll have negative into x minus 3, and here you can factor by minus 2 since 2 is a factor in both 6 and 2. So you're just going to have minus 2 into x minus 3. Notice that the x minus 3 and the x minus 3 will cancel. So you'll have a negative divided by negative, which is just going to be positive. So you have the limit when x approaches 3 from the left of 1 over 2. The limit of a constant is constant. So just gonna have the answer to be positive half. So that's how you can like evaluate this one. Notice how I like simplified this one. I didn't even have to use L'Hopital's rule on this one. But if you still want to use L'Hopital's rule, you can still apply it. But that means that you'll have to like differentiate absolute values, which I haven't really showed you how to do that. But now that will be in another video on how you can differentiate absolute values. Now to finish this video off, how about you just try to solve this one, the limit when x approaches 0 from the right of x to the power x. Pause the video and see if you can like work this one out. Okay, so how I'm gonna solve this, remember that e to the power ln c is equals to c where c is greater than 0. So we'll have to like make that assumption. But of course, now c, which is just gonna be x to the power x, is gonna be positive because we're approaching it from the right. As long as it's positive, and it's gonna be, so we can apply this condition because we're approaching this from the right. So that means we'll have a positive value of that. So that means that we can like use that formula now. So we have the limit when x approaches 0 from the right of e to the power ln x to the power x. So we basically use that transformation here. So now using the properties of logs, so you're gonna basically have this expressed as e to the power x ln x. So you have this now. So what I'm gonna do now, is I'm gonna transform this. I'll have limit when x approaches 0 from the right of e to the power x ln x. Now I'm gonna multiply. Remember, x ln x is the same as x ln x over 1. Remember, that's because when you divide by 1, it's just gonna basically be that number. So now I'm gonna multiply both numerator and the denominator by 1 over x. 1 over x. I'm gonna do that now. So I have the limit when x approaches 0 from the right of e. Now x will cancel with this x here, so you just have ln x. And 1 by 1 over x is just going to be 1 over x. So now you have this one. Now, using properties of limits, notice that e is a constant, so you can take that limit to be the exponent there. You can use this. It's in the properties of limits. So now you will have the limit when x approaches 0 from the right of ln x divided by 1 over x. Now notice that ln x, when you approach 0 from the right, if you graph ln x, it's just gonna basically be like this. So when you approach 0, you're gonna approach minus infinity. And now 1 over x, when you approach 0 from the right, if you remember, 1 over x is a hyperbola, so you're basically gonna approach infinity. So we have infinity over minus infinity. That means that we can use L'Hopital's rule on there. So that means that we'll have to differentiate the denominator and differentiate the numerator as well. So now you're gonna have the derivative of ln x is just gonna be 1 over x, and the derivative of 1 over x is just gonna basically be minus 1 over x squared. Then you have something like this. So now notice that here you can further simplify this by multiplying both numerator and denominator by x squared, or rather minus x squared. So I'm going to multiply 1 over x by minus x squared. What's going to be the answer when you multiply 1 over x by minus x squared? It's just going to basically be minus x. And what happens when you multiply minus 1 over x squared by minus x squared? The negatives will cancel, and x squared will cancel with x squared. Then you're just going to have 1 like this. So this will just be e to the power limit when x approaches 0 from the right of negative x. Negative x divided by 1 is just going to be negative x. So when we approach 0 from the right of negative x, well, what's going to be the answer? It's just going to be 0. So the answer will just be e to the 0, and e to the 0 is equals to 1. So that means that the limit when we approach 0 from the right of x to the power x is just going to basically be 1. So that's how you can like work out limits. Don't forget to share and subscribe. Thanks for watching.